Welcome to the world of artificial intelligence in gaming. This presentation explores how AI is transforming game development. From creating smarter characters to generating dynamic game worlds, discover the potential of AI in shaping the future of interactive entertainment. In game development, AI can be broadly categorized into two types: traditional and modern. Traditional AI techniques include finite state machines, decision trees, star pathfinding, rule-based systems, and behavior trees. These classic approaches have been reliable in game development for decades. Modern AI approaches leverage the latest in artificial intelligence and include deep learning models, neural networks, reinforcement learning, natural language processing, and computer vision systems. Let's explore them further. One of the fundamental applications of AI in gaming is controlling non-player character, or NPC behavior and pathfinding. Consider this basic implementation of NPC pathfinding using the A* algorithm. This code defines a basic NPC controller class with a constructor that initializes the pathfinding grid and a find path method that utilizes the A* search algorithm to find the optimal path between a start and goal point. The A* pathfinding visualization shows a grid where the green circle indicates the start, labeled as S, and the red circle indicates the end, labeled as E. The path showcases how the algorithm finds the shortest route, avoiding the obstacles in blue. Procedural content generation, or PCG, uses algorithms to automatically create game content, such as terrains, levels, and items. This example presents terrain generation using Perlin noise. The code uses a generate terrain function which initializes a Perlin noise object and iterates over the width and height of the terrain. It then applies the Perlin noise function to determine the terrain type at each coordinate. The generated terrain example illustrates a grid of cells, each assigned a color based on the Perlin noise value, such as water in blue, sand in yellow, grass in green, and mountain in gray. AI enables dynamic difficulty adjustment, ensuring that the game remains challenging and engaging for players of varying skill levels. Let's explore the Difficulty Manager implementation, which defines a class with a method to adjust the difficulty based on player stats. The Adjust Difficulty method calculates the player's skill and adjusts various game parameters such as enemy strength, resource spawn rate, and puzzle complexity accordingly. The AI-driven difficulty curve graph shows player progress on the horizontal axis and difficulty on the vertical axis, with a dynamic curve and a linear curve for comparison. This showcases how AI can create a more personalized and adaptive gaming experience. Machine learning algorithms can be trained to create more realistic and adaptive game AI. The neural network architecture for game AI diagram presents a basic neural network consisting of an input layer, a hidden layer, and an output layer, illustrating how data flows through the network to make predictions or decisions. For instance, let's look at the reinforcement learning implementation for NPC behavior. The reinforcement learning class code defines a train method that implements the Q-learning update rule, adjusting the Q value based on the current Q value, learning rate, reward, discount factor, and maximum future Q value. This allows the NPC to learn optimal behaviors through trial and error. Natural language processing, or NLP, allows players to interact with games using natural language, creating more immersive and engaging experiences. The dynamic NPC dialogue system example presents a conversation between the player and an NPC, where the NPC responds dynamically based on the player's input. Now let's focus on the NLP-powered dialogue processing code. The Dialogue Manager class defines a process player input method that analyzes sentiment, extracts key topics, and generates a response based on the sentiment, topics, and context. This demonstrates how NLP can be used to create more realistic and interactive dialogue in games. Computer vision enables games to understand and respond to the player's environment and actions in real time. Key applications of computer vision are gesture recognition, object detection, facial recognition, and scene analysis. The motion tracking visualization example illustrates motion tracking using computer vision, with tracking points and lines showing the movement of an object or person. The skeleton overlay demonstrates how computer vision can be used to recognize and track the player's movements. The future of AI in gaming is promising, with AI-driven storytelling that adapts and evolves based on player choices and interactions. NPCs will have advanced learning capabilities and realistic personality development. Game environments will self-evolve, responding to player behavior and community trends. Deep learning models will be useful for more sophisticated game mechanics and AI behaviors. Real-time processing enables instant adaptation and response to player actions. Comprehensive analysis of player behavior will ensure personalized gaming experiences. Finally, hybrid intelligence will combine multiple AI systems for more complex and nuanced gameplay mechanics. In summary, AI is revolutionizing game development through improved NPC behavior, dynamic content generation, and adaptive gameplay systems. Machine learning models are enabling more sophisticated and realistic gaming experiences. Natural language processing and computer vision are creating more immersive player interactions, and the future of gaming AI promises even more innovative and personalized experiences. If you are looking for learning resources, there are comprehensive guides available on implementing AI in game development, including code examples and best practices. Machine Learning for Games also has tutorials and frameworks for implementing ML models in gaming applications. Finally, connect with other developers in communities and forums and share knowledge about AI in game development. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.